This training video explains the usage and configuration of the camera tamper feature. Criminals often attack and disable security cameras so that they don't leave any usable CCTV evidence of their crime. All attack methods such as covering the lens, moving the camera, and defocusing the camera make gross changes to the CCTV image, which can be detected by the camera tamper software as shown by these three examples. Please note, by default, it takes 20 seconds for the alarm to register after the scene change, but to save time, I have cut most of the waiting time out of the video clips. Configuring the camera tamper for use couldn't be simpler. You just enable it, like so, and hit apply, and it is ready for use. On the whole, this is all the average user needs to know about the camera tamper function. However, there is a diagnostic mode which can be used for troubleshooting, which I will now use to explain the underlying operation of the camera tamper function. To switch on the camera tamper diagnostics, click on the Advanced tab and then tick the tamper debug box in the metadata area and hit apply. If I now go back to the camera tamper page and move my hand over the lens like so, then you will notice the red graphical boxes showing where the algorithm has detected a scene change from the long-term background scene. By default, the tampered duration until alarm is set to 20 seconds and the tampered screen area set to 40%, and so in order for the tamper alarm to occur, the algorithm must persistently detect a change in at least a 40% screen area for at least 20 seconds. So if I leave my hand covering a big area of the screen, an alarm will appear after 20 seconds. To further understand this point, I am going to demonstrate three different situations, two of which do not trigger a tamper alarm, and one that does. In each situation, I cause the scene change by moving a picture card into the camera's field of view. I am using the 40% screen area and 20-second default settings, but once again I have speeded up the action by editing the waiting time out of the video. In this first case, you can see that I have covered about 20% of the screen area with a picture card. Since this is below the 40% area threshold, no tamper alarm is triggered. After the 20 seconds has passed, the scene change is learnt into the background by the algorithm, and so the red boxes disappear even though the picture card is still there. This second case shows another non-alarm condition, where the duration of the scene change is less than the time threshold. The picture card is covering more than 40% of the screen area, but it is removed before 20 seconds has elapsed, and so no alarm occurs. In this case, the scene change has not been learnt into the background since the time threshold was not exceeded. In this third case, you can see that I have covered more than 40% of the screen area and held the card in place for more than 20 seconds, meeting both of the trigger criteria. As a result, the alarm is triggered. Notice that after 20 seconds, the red boxes have disappeared because the scene change has been learnt by the algorithm. So in fact, if I remove the picture card now, it looks like another scene change. And after a further 20 seconds, the alarm fires again. Please notice that there are three controls on the Advanced tab, which can be adjusted if the tamper alarm is falsely triggered by the normal camera scene activity. The 40% tampered screen area threshold can be increased if very close or very large moving objects occur naturally in the scene. Likewise, the tampered duration until alarm can be increased if large area scene changes of more than 20 seconds duration occur naturally. The final control is the suppress alarm on lights on off. Therefore, in these two cases, where there is a gross change to the image lighting level, no alarm is caused by switching the lights off or back on again, even though the camera tampering is enabled.